Okay, good afternoon. In some way I continue the presentation of Isabella because this project started from the idea of this thinning intervention from another point of view, particularly from the point of view of the climate change mitigation. In fact, the project was under the umbrella of CCM. We are about just finished the first half of the project, so we don't have the final results, but we have some indication. And the project is carried out in Italy and in Greece with a similar experimental pattern with in fact, both sides had three different treatments: control, traditional, and selective thinning, as we previously have seen, and with 3 replicates for each treatment. So we had 4 partners, 2 Italian, 2 Greek partners, and for both countries we had a scientific partner and the partner which was the direct planner of the areas, so the Forest Service in particular for Greece and the province of Firenze for Italy. Okay, so here we started from the same type of stands, which are artificial stands, but the lack of intervention during the last years generated a problem of degradation, really degradation. So we have a situation with really a lot of dead trees standing or lying, and so this generated several problems. So we had, of course, the increase of fire risk. We are in the Mediterranean area. We have susceptibility to adversities like pathogens. We have also low productivity. And the low productivity, of course, is, made the forest a lower sink for carbon, because, of course, if a forest produces less, the forest is also sequestering less carbon from the atmosphere. And so we have, this is why it's a problem of climate change mitigation also, because of course if the carbon sequestration is lower, then the forest is not a carbon sink, but can be even a carbon source. And also this is for the absence of regeneration. And another aspect is the reduced recreational attractiveness, of course, because people cannot enter in the forest. So the approach was multidisciplinary, because we tried to assess soil, atmosphere, and vegetation relationships. So we analyzed the 5 pools which are indicated by IPCC, which are the above ground biomass, below ground biomass, so the roots, deadwood, litter, and soil, which is a big carbon storage. Also, we measured the emissions, not only of carbon, so we didn't measure only CO2, but also methane and nitrous oxide, which are important greenhouse gases because they have a very big global warming potential, much bigger than CO2. And so we transformed everything in CO2 equivalents. And the last step was the production of bioenergy. So we tried to use the material cut from the forest as a substitute for the fossil fuels, producing bioenergy. So the impact, we had 3 main impacts, we can say. One is environmental, of course, because our goal is to increase the carbon sequestration, control the greenhouse gas emission. Of course, we cannot, we think that we can reduce the greenhouse gas emissions from the thinned forest, and of course to increase forest stability and regeneration. So to allow this carbon sequestration to go on in the next years. We had social benefits, social impact, because these are peri-urban forests, are very close to the cities, and so these forests are, a lot of people enjoy these forests, and so the goal in this case is to improve and to increase the attractiveness of the forests for the public, and so to increase, of course, the recreational value. And the other aspect is economic, because the use of biomass for bioenergy production as fossil fuel substitution, of course, has an economic value. And so we analyzed the whole wood chain from the forest to the energy, and also how to acquire carbon credits from these thinning treatments. So from the environmental impact, we know that the 4 pools, I mean the 5 pools, because we have soil, litter, biomass, above and below ground biomass, and deadwood. And so from the first 2 years of the project, we have seen that we had an increase of carbon into the soil, an increase of litter of the forest floor after thinning, because of course thinning generated itself litter. We had a reduced carbon stock, of course, because we cut trees, and so we had a reduced carbon stock of living trees and also deadwood. Then from these carbon pools, the next step is carbon sequestration. So we measured before and after thinning intervention, and we also had a percentage difference between thinned plots with traditional and selective thinning and control. This was true for soil, this has been done for soil, litter, and deadwood, and for the biomass above and below ground biomass, we are using, but we still don't have the results. This will be ready at the end of the project. But the approach is to use the increment, so the net primary production of the forest. And in this way, putting all this data together, we added the carbon sequestration of the forest with the different treatments. Of course, this, the other part is the use of wood chips for the bioenergy production. Then we have the other side of the story, because we have carbon sequestration from the trees. We have, of course, the greenhouse gas fluxes. Well, we are losing carbon. It's a natural process. And so we measure the tree gases. We transform everything in CO2 equivalents. And so then we had, we will have at the end the possibility to have a net result, subtracting the CO2 equivalents from the carbon sequestration. So we have really the net production of carbon credits. So these carbon credits will be managed into the market, and here I show you really a first attempt, which is not finished yet, but we will use these carbon credits first for the continuous maintenance of the improved forest practices, so trying to go also in the managers, and to reduce the CO2 emission produced by other sectors. For instance, here we had in the municipality of this forest, we had this first attempt, so to quantify the CO2 emission and the environmental sustainability of a cultural event. And so we applied this method where we measured directly the waste produced by this event, the total number of visitors, and then through questionnaires to the organizers, to the exhibitors, and to the visitors, we tried to see how much CO2 has been produced, and also which are the economic results. And so, okay, in this case, is an example, of course. We had these environmental impacts. So the event, this type of event, produce these tons of CO2 equivalents, particulate matter, and volatile organic carbon, and so on. We had an economic values of CO2. And this, of course, depends on the cost of this carbon, which is changing very fast. Okay, at this moment we had these values, and also the economic results. So the FoResMit project intervened because our question is how many hectares of thinning should be realized in order to compensate the emissions from such event. We are speaking at the municipality level, of course, but this can be replicated to bigger areas. From the other aspect of the economic impact, we had the bioenergy production. We follow the whole chain from the forest, from the trees cutting to shipping, transportation, and to the bioenergy plant for energy production. And so we had this, cost analysis where we have an economic value of the thinning. So we had profits, we had cost, and so at the end we had a total cost of chips production, and also we had a minimum chip cost, which was around 44 euro per tons of chips. That is the cost that allowed to the thinning to be economically sustainable. Okay, then these chips was used for the bioenergy production, and here we measured, we calculated how much CO2 from methanol or fuel oil we saved for the production of thermal energy and electric energy. And so we, from the chipping, from the 12,000 tons of chips that we produce from the 10 hectares of the demonstration site in Italy, we saved around 500 kilogram of CO2, tons of CO2, and 500 tons of fuel oil to produce thermal and electric energy. The third and last aspect is a social impact. We already seen from the previous presentation the method that we used, that was the same for the two projects. And so we, the questionnaires to the visitors of Monte Morello, which is the Italian site, gave these results. So the visitors showed to prefer a mixed forest than a monospecific forest with a random distribution of trees in the space, and also vertical and horizontal differentiation. And of course, also people want some recreational facilities, in particular waste baskets, simply baskets, picnicking areas, which would improve a lot the attractiveness of the area. And the landscape after the traditional thinning was considered most suitable for sports activity, while the selective thinning was considered the best for contemplative activities. And the most important benefits provided by the forest is the tourist recreation, then air quality, and then the last, biodiversity conservation. This has also an economic implication, of course, because estimating with the travel cost method the the cost that visitors are able or are willing to spend to visit the forest, we had an economic importance for the recreational benefits, which increase with the thinning treatments, in particular with the selective thinning scenario. And of course, also in this project, we use several communication and dissemination tools from the website, information boards, networking, of course, workshop, we are here. And the end product of the project will be a manual with the guidelines that will be useful for the managers in particular, and that can be used for the replicability of the project. These projects, I think both projects with this type of thinning have really a high replicability, mainly in degraded pine forest in the Mediterranean environment, but not only. And I think in all sites where the succession in a mature forest can be accelerated in particular. And okay, I just thank you all the team and you for your invitation and your passion. Thank you.